Goedemiddag allemaal. We wachten nog eventjes op een aantal mensen die nog even moeten inloggen. En dan stellen we voor om over een kleine 2 minuutjes dat we gewoon gaan beginnen. Yes. Okay. So I think it's now about time to start. Thank you all for making time and joining our webinar from our community of practice circular economy together with Veridis. And the next hour we will discuss the breakthrough analysis technology for smart plastic recycling. And my name is Erik van Sprang, and I will guide you through the next 60 minutes or so, a little bit less. Yeah, maybe you do the next slide, please. So this is what you can expect, a warm welcome. After that, I will briefly explain a little bit about COAST and the community of practice to give for the people who are not familiar with our community. And after that, the people from Veridis will give a short introduction, and they will explain the potential of the MADSCAN technology in smarter recycling. And after the presentation, we would like to address the questions that may or may not occur during the presentation. And what we like to do is go into discussion and identify opportunities within your own, let's say, working environment, and which is actually really, I would like to stress to try to think along and also be critical in sense where can we improve and what can we do to make this work. Yeah, next slide, please. So briefly, the COAST community, it's a community of innovation with a strong focus on analytical sciences and technology. And what you see over here is our representation of our world. And in today's society, as you might know, is becoming more and more data-driven or information-based decision making, of course, due to the technology advancement and also the urge to feed all the potential what we have with high quality data. And what do we do within this world? We have basically 2 lines. We want to facilitate the innovations, so we work on the fundamentals, the research and development, but also the innovations and the implementations that people are really benefiting from the potential. And on the other side, we have, of course, the transfer of all these innovations, and we have a honors program where students on top of their own curriculum have additional courses, and also they do internships with members of our community to practice or implement these innovations and derive from that the best practices and learnings. As you can see, currently we have 4 focus areas. We have the community around the pharmaceutical industry. We have the water, people who are familiar with that, the Water Framework Directive. We have the analytical core that's really focused on the hard metals, so the all AI developments within R&D, but also manufacturing. And today, one button more down, circular economy. This is our focus. Next slide, I will share a little bit more. What does it mean, this community of practice? Yeah, you can look at it as an active learning community, and working together with the knowledge institutes, the market, and of course the students. And together we have a proactive community-driven approach, and the topics that are of interest are the ones that are, let's say, derived or proposed from the market, since there is an issue and we want to solve it. The approach is, oh,
Sorry.
yeah, the approach, yeah, no worries. The approach is an active learning approach. And it's a combination of workshops such as the knowledge transfer, but also use cases. And that's what I meant before. At what you hear today, we would like to ask you to see if this could be something of interest for your own working environment, and that we can start working together on a use case. And the outcome can be from best practices, insights, prototypes, and so on. The reason why, I think it's very obvious, you want to move forward. And the activities, well, you see on the right side, that can be internships, that can be hackathons, feasibility, technology validations, public-private consortia, and so on. It's just to give a little bit of feeling what the community is. If we move one further, having said, then we move towards our webinar. Of course, are there any objections against the recording? If so, please let us know. If you have questions, also, would you place them in the chat, because after the presentation we will address them one by one. And of course, we would like to send additional information using your mail or via LinkedIn. I think this is in a nutshell our game rules. I think we can go to the next slide. Introducing our presenters of today. We have two people from Veridis. We have Marie-José, and she will share a little bit about the technology, and Daan will also tell us all about the progress what technology has done in recent months or maybe even years. So I guess the floor is yours.
Thank you, Eric. Thanks for the warm introduction, and we're happy to be presenting today in the TI COPO webinar on the circular economy. And before I start diving into the MADSCAN and everything, thank you everybody for joining online. If you have questions, do it at the end, but we open then up to like an interactive session to have some discussion. So we're really looking forward. And next to me is
Marie-José Wolters. Yeah, you can see my name on the screen. So looking forward also to present to you some slides and to have some discussions after the webinar.
So if you want to, for instance, still connect with Eric, you will find his details on the slide. So today we're going to talk about the MADSCAN technology and how MADSCAN is enabling high quality recycling through the whole value chain via smart plastic analysis. And we first start with the problem. Currently, 98% of the plastics globally are not recycled into high quality, meaning they don't end up in a similar product. Only 2% of global plastics are recycled into high quality, and we actively try to engage in this field to make sure that this 2% goes up. Why are these plastics so hard to recycle? There are over more than 250 types of plastics, and it's not possible to collect all these plastics together. If you look at the screen, you, for instance, hear terms like rigid, flexibles, technicals, PET, polypropylene, polyethylene, and these cannot all be recycled together, because if plastics main fractions combine, you get voiding of materials, immiscibility, creating a poor product quality. For instance, films tear, rigids become brittle, though the ambitions in the EU are very high. We're aiming for 2030, 30% recycled content in packaging and food materials, and 100% circular plastics in 2050. And this is just an example of the packaging industry. If we then simplify the circular plastic value chain, it starts with collection and pre-sorting. Then the sorted bales end up at a mechanical recycler or a chemical recycler. Then further processing takes place, for instance, via extrusion, and the converters then turn the recycled compounds or granules into an end product. Here you see that MADSCAN can measure at any stage of this process. But how does the industry currently measure composition and recycled quality? Inline, often optical scanning techniques, such as near-infrared spectroscopy or mid-infrared spectroscopy, are used next to line. However, these technologies cannot see black plastics. They only scratch the surface of multi-layered plastics and cannot detect compounds. Another technique that's often used, or a class of techniques that often is used, is thermal analysis. Only can be done after extrusion. So extensive sample preparation is needed of the recycled flakes. And the scale is not representative because it only can measure a few milligrams at a time. So currently, recycling quality control falls short due to inaccuracy of technologies, leading to a loss in quality, or the technologies are not fit for the industry, so don't represent skill and speed that the industry needs, and is not fit for all plastic types and forms. So currently, we found out that accurate measurements are only at the end of the recycling process, which leads to no optimization of the recycled feedstock stream anymore, production stops, and inconsistent outputs of recyclers, leading to high costs at the producer's end, so the converting end. If we then zoom into the recycling chain, you take a bale, which is then mechanically recycled into flakes, which are further extruded into a granulate or a compound, which is then converted further down the value chain. If we take an alternative route for chemical recycling, giving the example of pyrolysis, often this step is shorted or all the excluded materials are agglomerated and sent to a chemical recycling facility. But what if you could measure earlier on in the process with novel techniques like the MADSCAN?
Yes, and we have the possibility with the MADSCAN to measure on flakes, so earlier in the process. And how do we do that? We do that with a thermal analyzer, which is 10 times bigger than the current setup in the market. You need just a simple preparation, and the sampling you can also do on other formats like granules, agglomerate, so not only on flakes. Besides that, we determine not only the main polymer, but also the subtype. And we do that by a thermal analysis, so that means that we are heating up and we cooling down. Every polymer has its own distinct way of crystallizing and melting. This is what we're picking up with the data, and on that way we can tell what kind of polymers are in your feedstock. Oh, next slide, Dan, please. So first, we will make a slab or a cookie, and we can do that directly from the recycling process. So that means that when you have flakes or foils or whatever you want to measure, first we make the cookie of that with a sample prep tool, and this cookie is 3 millimeters thin and has 50 grams. So this cookie in the next slide, please, Dan, we put it in the MADSCAN between the heating and cooling element and the sensor array. We're picking up the data, we're making the graphs. And what's also very nice, besides the fractions of the polymers in your feedstock, we can also give the distribution of the polymers in your slab. And this is depicted in the right image. You can see the black and white, which represent another polymer. Next slide, please. So here you see the system in live. We are now in Hillegom, and the two machines, the first machines are also there. So what's very nice to see is these are robust machines. So that means you can place them also in an industrial environment next to the line. 50 grams, 1 to 2 hour measurement, and we can measure all kinds of polymers like polyolefins, PET, polyamide, ABS, and PS with an accuracy down to 1%, and we have 240 sensors on board. So here you can see the chain. What is important to remember is that we not only can measure on granules, but also before the extrusion process and after the sorting process. Because when you measure flakes, you have the possibility to do something. You can sort, you can adjust your recipe, or you can add virgins. And also we have the possibility for chemical recycling process to measure on agglomerates after agglomeration or before. What we did the last couple of years, months, is we measured samples. More than 400 customer samples were measured. And we always share the results in a meeting. And what we see is that the analysis sometimes match the expectations, but more often analysis deviates negatively from expectations because there were higher contaminants in the feedstock or unexpected polymers. So main is that there is not really insight in your product, and it's necessary when you want to go for high quality products. Can you go to the next slide? Yes. So some examples. So problems occur more often at the converter. So when you make the product. So we have some use cases, for example, with an injection molding process with PP. When there is too much PE in it, then then you have quality or process problems. So this is one of the examples we found out. And injection molders often send us granules and not flakes. So we encourage them also go to your recycler and ask them for the flakes, because you know when you know the composition of flakes, you can do something, and in collaboration you can work towards a nice granule fit for the process. Another process which is also used very often is an injection blow molding process. You find this typically at packaging lines where preforms are supplied by a supplier, and then at this line in high speed the preforms are filled with air, and the liquid goes into the bottle. And in this case, when there is too much PP in your LDPE recyclate, you find cracks on the welding line. That means reactions of the product and production stop, and that means high cost because of this. Then another process we have in the market is blow film extrusion. Besides contaminants, which occurs gels, it's also important to know the ratio LDPE, LLDPE, because this determines the quality of your film. In collaboration with a German party, we analyzed a lot of this kind of granules, and in 43% of the 71 we analyzed, the results did not match in line with expectations. So the question is, what does quality mean when the spec sheet and composition don't match? So to walk the talk together with consortium, in the consortium post-consumer to Prime, together with Nourion, Brooswater, the compound company, and Tremelin, we will develop recyclate near to virgin prime, and this is subsidized by the Dutch and European government. And with this recyclate, we will make rain blocks with an extrusion blow mold process. You can show also the next slide. And in this case, it's also important that you have, a high viscosity and a low MFV. And that's why we are also looking for regrinds, HDPE and PP. So if you have some products, yeah, you can contact me. And in the next slide, you can see also on the right bottom the web page. So the recommendations we have for the recyclate market, for the recyclate market, early measurement in the recycling process, insights enable clear alignment based on facts, and collaboration in the value chain by insights. Interested in more MADSCAN information, you can ask me or Dan, and of course also go to our website. And we have also some nice papers there, together with the Radboud University and the Fraunhofer Institute. So that was it from our side. Thank you.
Thank you. Thank you for the, I think, a very clear presentation. So one of my first questions is to the audience. Whom of you recognize this story and sees opportunities or have some critical questions around what was just presented? Well, let me see who is in the room. So let me see. For instance, Lisa, can I ask you to give a comment on what you just heard? Because one of the questions I had was listening is how the insights that you're running a lot of experience now, and the insights you gain with your technology, did the end user translate that into, let's say, being able to make, for instance, can they design control actions based on these insights in terms of quality? Is there something what you experienced, Marie-José or Dan?
Yeah, so what we often see is like in the industry, we gave examples now at the end, right? From a granulation point. We see that customers say that, like, yes, indeed, we see that there's contamination of a low amount of PP or PE, dependent on the process. Try to go back to their recycler and get higher quality grades. But then the door ends there. So it closes for the converter. And this is a reason why often converters are still a little bit skeptical using recyclate. What we want to encourage is really going back in that chain. And on the flake measurements that we already did for foil recyclers, for instance, the example that Marie-José gave, we see that there is movement, yet the industry needs to convert their mind as well. Due to the current economical situation, it's sometimes hard to go to that higher quality because you need to tune your processes still. And time is money. So it's like a double-edged playing field that we're in currently. What we really want to encourage in this webinar is that the insight can be done on the flake level, and then we can measure even more accurate than only on the compounds. That's really the main message here. So if people have questions or maybe challenges that they see, we're happy to further discuss. I hope that tackled your answer a little bit, Erik.
Yeah, it does. It was insightful. Oh yeah, thank you for joining. So I see already some people are leaving, unfortunately. I was also wondering the speed of making this cookie.
Yeah.
Question.
It's a super good question. So if you look at the two cookies we have over here, it's this is an example for flakes of rigid materials, so LDPEs. These are some examples of foils. So it's a flexible slab, as you can see.
Yeah.
And dependent on which polymer type you want to get prepped, the speed varies as well, because some polymers are hygroscopic of nature. So for the polyolefins, it takes approximately half an hour to prep a cookie, but it's a hands-off process. You only need to pump 2 times. Once you have the cookie, you load it into the T50 and you press the button run. And maybe that didn't came completely clear yet, but then the algorithm just does the whole analysis. So it's hands-off. So basically, we design the making of the cookie that the operator could do this. It's just cracking a slab. On the machine that we use for making the cookie, it's like per recipe, a recycler can just press the button and it will run the heating curves correctly. So we optimize it for the recycler.
Yeah, because I'm thinking, if you, the earlier in the chain, then, you have the cookies and the insides for, at the end, the compounding. And if they have, really good knowledge, because I was surprised about we have spec sheets and we have the reality. And which for me is a little bit, well, of course, we can expect it, but it also means that there's a lot to gain in really understanding what do we have and what's the impact of that on the quality of my end product, right?
Yeah, and what we see is that the recycling parties are really putting lots of efforts already in. So if you look 10 years ago and now, there's like standardized working ways already that they measure quality. But that's often not on the composition, but purely on the melt behavior. If you, for instance, look at foils, because you're dealing with like a super high intensity, high throughput process. So that's why really, only a milligram on a DSC is too slow, because already everything is through the whole recycling line. And that's where we really see that on batches that are not performing with the inline measurements, that we can give an additional insight. That's really where we have the call to action to everybody in the audience.
Yeah, that's clear. So I was wondering also in terms of representation, right? You did some work with the Radboud University. Is one cookie enough, or can you say something about that?
Yeah, so that's a good question. So currently, the Radboud study was on our prior system that used maximum of 30 grams. So if you look at the slab, it's only like a small portion of it. There we already saw that if you sample correctly, of course, sampling is needs to be done at the correct points of your process. We can hit 98.5% accuracy for polyolefin matrices, so rigids and films. With the T50, we expect to even increase that further for a ton of material. And why is it that ton of material? A recycler often trades in big bags, which are between 500 kilograms and a ton.
Yeah,
so you can get one big bag once you release it directly.
Yeah, and you also help people with the sampling strategies, right? That they take the right or create the right cookie.
There was this study also all about. So how do you take a sample? So this is also very engaged. Yeah.
And we also compare the MADSCAN. So the benchmarking is done compared to more knowledgeable techniques, I think, for the analytical crowd here, towards GPC. How well does a GPC represent chain length? But also we compare to FTER with ATR, which is of course like a point scanning technique. So it will take you a long time to measure all those flakes. And we do some recommendations together with Fraunhofer. So that's a bit the summary what's standing here.
Yeah. Okay, nice. So and if you think about the information you generate, so let's say the composition and the percentages, the fractions, is that enough, or do you think you need more information included in terms of chemical knowledge? But stated differently, with the amount of information you guys already give the insights, you can already make a big difference. Is that or?
So what we are doing is the polymer composition, but there are also other measurements which you need, for example, mechanical testing, MFV, and you need the complete package. But in this case, also you can correlate.
Yeah, so there's a correlation between all these technologies, and what we do currently, if we give like a example of where we do this, together with our partner Plusship in Germany, we are building an artificial intelligence platform where we look at benchmarking of recycled content. One technology doesn't tell all the details. What we see is like with the measurements, you get now like basically 10,000 times the information of a DSC, which is super accurate. Of course, we do some different tricks in the MADSCAN that are proprietary, that we can get some additional insights as well that a DSC can't. So I think really there is the answer. You really need to collaborate, have all the information, and digitalization is key in this sense.
Yeah. No, that's clear. So yeah, I think it's a very, very, very clear story, and also the benefits, at least for me, the potential is I think very, very, very high. So myself, I don't have any questions. So if there are any questions left in the audience, or if you want to reflect on it. Thank you. Yes, thank you for joining us. But keep it back in mind. You can always contact us for more information, or if you have a use case in that might be of interest, please let us know, and then we can move from there. So So I guess if there are no more questions, I want to thank you very much for the clear presentation, and hopefully see you guys.
Also, thank you for having us in this webinar. Thank you very much, Erik.
Yes, sir. Yeah, thank you. Okay, guys, have a nice day. Bye-bye.